Hello, welcome back. So today we are working on a carrier package rooftop unit. This unit is serving to the offices of a HVAC company, and they are saying that the unit blew up one of the fuse. They replaced it, and after that, the unit wasn't working. So I have already turned off the main disconnect switch. So it's an electrical troubleshoot. So we have to check all the high voltages component, show to ground, or if they are burned or something. So this unit was installed a year ago. Looks like a new unit, so I'm gonna also check with the supplier if they are still under warranty. If you see here the serial number, just like Lennox, '23, so last year. So we're gonna open up and start. Okay, so I have opened up the electrical section and the blower. So this unit has a fancy direct drive variable speed blower motor. So it's November and the ambient temperature is like 5-6, and definitely it's a cold season, and the unit blew up fuses. My first thought gonna be on the heating side, what are the high voltage component? First is a venter motor and the second one is the blower motor. So we're gonna check those short to ground, and we're gonna check the proper incoming power supply. And before checking that, before turning on the power, I'm gonna disconnect the thermostat R terminal from the control board. Okay, let's start. Okay, so I have checked the venter motor. It is showing continuity between all three wires. So looks like our venter motor is okay. The second thing is the high voltage component is a blower motor. So this blower motor is not jammed, as you can see. It's rotating freely with the hand. But the thing is, we cannot check directly its winding through this plug, because as you can see, it's a high voltage 3-phase motor. If we check the spec label here, it says indoor motor 575 3-phase. So but here it has a multiple wire, so these three, like 4 wire, 3 would be the phase and 1 green is ground, and all these small wires are for the speed, which is connected here. If you can see here, this plug, and this is the speed. This is the board where we can slightly increase or decrease the speed of this motor. So my point is, we cannot check the winding from these 3 phase wire, because these are going to a, I think, the kind of ECM module, which kind of electronic circuit control board like this one, or variables. You might have seen the variable control board, and then after that it's going to the motor, main motor. So it's inside. So we cannot check the continuity or resistance through this wire directly. So let's turn on the power, check the voltage, low voltage and everything. Okay, let's turn on the power. I have removed the R thermostat wire from the control board. Is there any light? Yeah, just see. Yeah, the control board, ignition control board, is having a LED light on. I have set my multimeter to the voltage setting, and I'm gonna check the incoming power through this terminal. Line 1 to 2 606, line 1 and 3 606, and line 2 and 3 605. So we have a proper incoming power supply. Let's check our low voltage. So between R to C, we have 27. Sorry, yeah, 27. So we have a proper low voltage and high voltage. Okay, I have jumped between R to W1 to check the heat, and yeah, let's turn on very carefully. Venter motor, as I said, it was okay, so unit fired up properly. So my only doubt is now on the blower motor. Let's see if it's turned on. Hopefully that will not blow up any more fuses. I'm just going a little bit far in case something happens. It's cold outside. No, it's not coming on. I had the click on the board. I think it's a relay. It clicked, but the blower motor is not coming on. Okay, let's turn it off. Okay, so I have disconnected the motor plug, disconnected the power, of course. So let's see how it is mounted. So I can see these two screws, and after that the back they have a slot. So we just have to remove these two screws and these two wire, of course, and then the whole assembly will come out, slide out, and then I will manually open the motor cover to verify if it is burnt or something, or what is going on inside. Okay, so the motor came out very easily, and so I think the motor is right underneath. Let's open it and verify what is going on. Okay, check here the burn mark here, and this ECM module, I don't know if you can see, but this portion is completely black, burnt. So that was the reason it's not working. So this is the ECM module, and which connects through this terminal to that, and here is our motor. So this has five terminal. 3 should be for the high voltage. This is 575 3 phase, and 2 for I don't know. And looks like that's gonna be a very expensive motor. Okay, I'll check with the carrier if the unit is still under warranty, and we're gonna get the new motor. Okay, so we are back with the new motor. The carrier was saying that the unit just passed its warranty period, so it's not covered under warranty. And this blower motor is way expensive. It's like double the price of the conventional belt driven motor, and they are saying that it's it would be better if you change the ECM module. For sure we saw the burning on the ECM module and the motor, which we didn't check, so they were saying that to change the whole thing. And so we got our new motor, so let's verify the electrical spec with the older motor. Okay, new motor is a little bit like from outer side is a little bit different. Even the part number is also different. They have upgraded it. And if we check here on the label, it says 575 3-phase and 2190 RPM. That's the new one. Let's check out this one. 3-phase, 575 volt and 2190 RPM. So the specs are same. And this is made in Germany. Company is EBM. So EBM motor, they are like a very good quality motor, but I don't know what happened to this one. So okay, let's open up this one. Okay, so first we have to take that shroud out, and then this fan, and now these are the mounting bolt of the motors. So this is the first time I'm changing this type of motor. Okay, new motor back in, so we just have to match this slot here, and rest everything will match, I think, the mounting bolt and everything. Yeah, so we're gonna tighten them. Okay, so everything is back in. Assembly was very easy. The only thing was cost. This is very expensive. So now I'm gonna check why this motor got burned. So I'm gonna recheck the tightness of all the electrical terminals, maybe the loose wire or something. Okay, so yeah, so when I was checking the tightness of these wires, so I found the red one. Now I tighten it like it goes like a quarter ton easily, yeah. And rest these two were like tight. So I think that would be the cause, maybe the loose wire. So formally it was getting a 2-phase power 24-hour, but sometime it was losing a power from the mid phase. That could cause the burning. I hope that was good if the compressor didn't blow up. There is one more difference I have noticed between these two motors. If you see, there are like 4 holes on the body of this motor, and here it doesn't have any, nothing. Okay, so I have installed the new motor back in. So high limit wires connected, the main plug is connected, so it already been jumped between R to W1. Okay, let's give it a try. Going a little bit far. Hopefully everything gonna be okay. It's rotating. Okay, it's working. So I think that the loose wire, that was the cause of the motor burnout. Okay, so this is the label where carrier has explained how to set up the proper RPM here. So this is the chart and these are the instructions, and I'm not gonna touch that because I think it has already been set by the factory default. So just for a recap, I just wanna, so I think our cause of motor burner would be that the loose wire I found, which was going the one of the three-phase power supply to the terminal block, and I found it loose. So I think that's the only cause, because these motors are very good quality and they rarely go bad, and that was very expensive. So so they used the same old disconnect switch from the previous unit, and I think the connections of the disconnect, they haven't touched that, should be okay. The only thing, when they connected the power supply from disconnect to the new unit terminal, then they did not fully tight. So okay, so that was for the today, and that was my first time changing this kind of motor, and thank you for watching. See you next time.